Welcome students, this is the 8th class on digital land surveying and mapping. In today's class, I am going to demonstrate a few GPS receiver, then some sample softwares as well as the field demonstration of the method of surveying that will be required to be done for establishment of control point. So, the class will be consisting of these points like introduction, demonstration in the class and field demonstration of positioning of control point. Now, as we already know that GPS receivers we do place at the point for which we want to establish the control point. After setting up the instrument, it is the software that is placed inside the receiver that will be used for doing the different operations for receiving the data, and subsequently that data will be downloaded to office computer using again some software, and the data will be processed also using some software. So, GPS softwares, there are different types of GPS softwares that we use for GPS data collection as well as processing, and some of them I will demonstrate in this class. And while we are collecting the data for establishment of control point, we do make use of the method of static positioning. Either it may be in autonomous condition or it may be in relative condition. So, that type of GPS positioning will be shown in your field demonstration. Now, I will demonstrate a few of GPS receiver. Now, you know that the GPS receiver may be of two types, then single code receiver as well as frequency receiver. I will show you two types of code receiver. One is single code receiver followed by a dual code receiver, and I will show you three types of frequency receiver: single frequency receiver, dual frequency receiver and GNSS receiver. So, the demonstration starts now. Now, let me show you one of the single code GPS receiver that we generally use for reconnaissance survey is this one. However, there are hundreds of varieties of single code GPS receivers are available, and most of the GPS enabled mobile phones are also associated with CA code or single code GPS receiver. Now, this is a dual code GPS receiver, and this receiver may be used for mapping purpose. Let me now demonstrate you a single frequency GPS receiver. Now, here you can see a receiver where this is the antenna and this is the receiver and this is the controller. Receiver and controller are together and they are connected to antenna using a connector, and they are mounted on a tripod stand. So, this if we take this arrangement outside this room in open sky, then through this antenna we will be able to get the GPS signal and record it through this GPS receiver. Now, let me demonstrate you a second dual frequency GPS receiver. Here you see a dual frequency GPS receiver where this is the antenna of the receiver and the receiver as well as controller is this one, which is connected using a connector, and it is been set up on a stand. Now, if we take this instrument outside in open sky, then it will be able to receive signals dual frequency L1 and L2. Now, let me demonstrate you a type of GNSS receiver. Now, this is, you can see, this is the antenna, geodetic Zephyr antenna. This is the antenna which is useful for very precise measurement of position, and this is a receiver and this is the controller. Now in this case you can see all the 3 units are independent to each other and they are connected using some connectors. Now this receiver can receive signals from GPS satellites as well as from GLONASS satellites as well as from ESBA satellites. So this is a very powerful receiver. The signals can be useful for many precise measurement activities. That is all about the demonstration of GPS receiver. Now I will demonstrate some of the GPS software that we use for collection as well as processing of GPS data, and these softwares may be divided primarily into 2 types, that field software and office software. And under field software I am going to demonstrate about the firmware, operating system software, controller software and real time software, and under office software I am going to demonstrate the interfacing software, then post processing software. And under post processing there are 2 types, one is that commercial software and scientific software. Now let me start the demonstration of GPS software. Now let me demonstrate about firmware. The firmware that is available inside this controller, that we can get by first tapping the start menu. Once the start menu is coming, then in that menu we will get the setting, and inside the setting we will get the system, and within that if we go to system information we will get the information about the firmware by tapping the info. So like this we can have the information about firmware inside this system information for any controller or any other hardware we use in GPS serving. Now let me tell you about operating system software that is working inside this controller. Now in order to know what is the operating system software that is working inside this controller, we go by start. First we have to click start, then we should click to setting. Inside the setting if we go to the system, and inside the system if we go the about, then it will provide us the information about the operating system, that is Windows Embedded Handheld 6.5 Professional. So in this way we also know what is the operating system and further work on operating system can be done. Now I will like to demonstrate on controller software. Controller software that is available inside this controller. To find out the controller software that is being used by this controller, we first tap the start, and here you can see in the start menu itself this Trimble Access is the controller software that is available within this controller. So now it is opening. Now this is the opening menu. So here we can see we can go for general survey, then equipment management, settings, other things are there, and this is an access sync which gives some connectivity between different units to be operated. So we will be learning in detail about this afterwards. Now let me demonstrate about the real time software. So, real time software, in this controller there is a very powerful real time software which is called SatNav, that we can get access through tapping the start and so you can see that Sat Viewer is the name of the real time software that is available. Now, since we are inside this room, it is unable to capture the GPS signal, otherwise this real time software will capture the GPS signal, and also it will provide us the latitude, longitude, speed, azimuth, height, so many parameters. It will also show us the sky view of the GPS satellite. Then like we can get the GPS data view if some data comes. So, now I will like to demonstrate you a software which provides connection between the field computer and the office computer, that is called software to connect the field computer office computer and the software that is being used by this controller is the ActiveSync. In this controller we can get it from start menu. Actually this is the very fundamental thing, so it is available in the start menu itself, that you can see here ActiveSync. So, once we get connected, then this arrow will move. So, now we are not connecting, so it is stand still now. Let me now demonstrate the post processing software. Among the post processing software there are two types, as I already told you, the commercial software and the scientific software. So, first I will demonstrate the commercial software. Of the commercial software there are again two types, one for code processing only and another for code and or frequency processing. So, for code processing one of the sample software is GPS Pathfinder, which I am now demonstrating. It contains many modules. The content of different modules of the software are as follows. So, now I will demonstrate the frequency processing software. The sample software is GNSS solution. So, here you can see also it also contains many modules, it works for different modules. So, I am showing you the different modules that this software contains and different functions it can do. Now, I will like to demonstrate the post processing scientific software, the Bernice software version 5.0. It also contains many modules. The contents of different modules are as shown. Next, I will like to demonstrate the real time software, which is RTK Post. Actually this software can also be used for post processing work, and the different modules in this software are as follows. Finally, I will like to show you one planning software which is GNSS radar software. In this software, if you give the latitude and longitude of the place and date and time, then corresponding to that latitude long and the time date, you will get the approximate number of different types of GNSS satellites along with the different criteria like dot values and all these things. So, this software is useful for planning purpose. With this, I conclude the demonstration of GPS software. That is all about the demonstration of GPS software. Now, I will take you to the field and to demonstrate the static method of GPS positioning, in which I will first demonstrate the autonomous positioning, where I will set up the single instrument and that data from that we can make use for establishment of control point. Then I will show you relative positioning considering the reference as well as rover. So, the demonstration starts now. Let us do the point positioning. So, at the time of point positioning, first we have to identify a station on which we have to set up our instrument, and that is generally known as reference station. So, this one is our reference station. Here we have kept a pointed, so that is the for centering purpose. So, after identifying the station, we have to keep our tripod stand. So, this is the tripod stand which we are like to set up on this. So, before setting up, we have to first open it and take it out to as much height as possible, convenient to your height. So, now we are fixing it. After raising it, now we have to take it, spread around it in such a way that all these three legs should be spread well, equally spread, and this should look through this part to make the approximate centering, as well as we have to make the leveling approximate. So, approximate centering and approximate leveling has to be done spreading the legs of this tripod stand. After that, we have to take the tri-back. This is a tri-back, along with this is the tri-back, and this is the antenna adapter. Both are put together, and before we are placing it on the head of the tripod stand, we have to take these foot screws in the middle between the tri-back and tri-back, so that approximate leveling is to be done, and that you can see through this bubble. There is a bubble where you can see about the leveling part. Now, we will fix it. So, this is the optical plummet of the instrument through which we look through to see whether our centering is just on this tip or not. Now, by adjusting this tripod leg, we have to make it level. Leveling we will be able to understand by seeing the bubble at the bubble tube. It should be at the center of this bubble tube. So, now it is level. Now, we have to check whether centering has been done. Now, this part has been centered properly as well as level. This is a very important operation to reduce the amount of grass error, as I had discussed in errors in GPS observation class. Now, we will fix the antenna. This is a very high ended antenna called geodetic Jeffrey antenna, which removes the multipath errors So now we are fixing it. So taking the adapter here, placing it. So this is how we have placed the antenna. Now we will connect our antenna with the GPS receiver. Now this antenna will be connected using this connector to this receiver. So in this receiver there is a symbol where it will be easily understood where you have to make it. So there is a symbol of GPS. So because this antenna will receive the GPS signal, so we will be, so now it is connected. Next we will connect with this receiver the controller. So already I had shown in the class, this is the controller which we will be using here. So one end of the controller will be placed here and the other end will be kept here. So after this we have to, so the battery is already within this part as well as this part, so we do not need any external battery for our work. Now we can start. So one thing we should note that after connection is over, we should be as far away as possible from the antenna, because otherwise the signal will come GPS from our head also, it can go to here, which may cause multipath. Now you can see our arrangement, we have open sky, and you can see if we take an approximately 10 degree or 15 degree, so there will not be any obstruction, physical obstruction. So that is very important. So we have taken our reference station on the top of the roof. After the receiver has been set up, that means antenna has been centered and level on the point or reference station and the proper connection with the receiver as well as controller. First we have to make this controller open, so that after opening we get this screen. Now from the start menu we can go inside and we can see the Trimble Access is the field software which is to be used for our surveying work. So this is to be opened. Now it is opening. So this is the first menu. So now we have to open the general survey. So here you can see here the 95% is the amount of battery charges that is available here, then the then another 91% is from the receiver. So anyway, so now here you can see the satellite, there are 8 satellites we get connected, and the our controller is properly connected with the receiver. So it is giving an antenna is also properly installed. So now we have to go for jobs. We have to create a new job. So we have to give a name. Let us say the job name is job 1, first job, job 1, and keeping all other parameters okay. Now we will not be changing any other parameters. So we can also COGO settings, we can do it here. The if we want we can change some of the, like sea level, we want to get the height with respect to sea level, then we can tick it, accept. So we have accepted, that means job has been created. Now we have to start measurement. Now if we click, we can go inside the measure, but before that we can also check. You can see here PDOP is 2.1. So in our lecture class already I told you, if the PDOP is less means we have a very good geometrical constellation of satellites. So we can start our work. Now let me click to fast static. As I told you that the fast static is another version of static surveying. So when the duration is less, then it is fast static, because we are going to take small duration observation. So we have started with fast static. Now start base receiver. Since this is the reference station and also it is called base receiver, so we are starting the base receiver, and we can give a name to this point. Let us say this is the point, our reference point. So roof top reference. So this is the name given to it. So now we had to measure the antenna height. Now antenna height can be measured. This is the way how we do take. This is called slant height, and the height is how much? 1.09. 1.09. I am to feed it and measure to bottom of notch. So now I can start taking observation. So starting survey, this the base started, okay. So now the measurements are being taken by the through the antenna to the receiver, and the observations are being recorded inside the receiver. Now we can exit out of it. Now it will be continuing to take. In the meantime, we can go for next method. Now after our reference station has been set up at the reference location, or base station has been set up as the reference station. Now we will be setting up the rover station for our relative static positioning. So this is the point whose location we need to find out. So we have to centered as well as leveled our tripod stand on this point. So similar to what we did in the in case of reference station, we are doing the same thing. First we are opening the tripod stand and we are raising it the height, and then we are taking the tripod stand around it, so that the tripod stand is centered over it as well as more leveled. Then we will be taking out the tripod head, tri-back head along with the antenna adapter. So after taking these 4 screws in the middle, we have placed it here, and now we will make it leveled and centered. This is the optical plummet through which we see about the centering, and this is the cross bubble which provides us the level part. So now this tripod stand has been centered as well as leveled. Now we will be fixing up the Zephyr antenna, and we are placing it on the tri-back. So after the antenna has been placed on a centered and level tripod stand, now we will be connecting the antenna with the rover receiver. So again on that port where GPS has been written, and with this rover now we have to connect the controller. We are placing the receiver in the tripod stand itself. So now we are connecting the controller wire with the receiver. Now after getting the wires connected as required, now we will start. Now after making the controller on, this is the starting menu. From the start icon we are getting this starting menu. So Trimble Access is the fields software. So we are opening it. So, it is open. Now, we go to the general survey. So, from the job we are opening a new job. So, say it is job 2, enter, accept. So, now we have to measure. So, because it is a relative static method, so we are taking the static as our option. Now, we have to measure point. So, we can give a name to this point. Suppose it is rover 0 1 and method. So, antenna height, again we have to measure the height of the antenna using the appropriate measuring stick. Since we want to measure the height of the height of the field, so
1 point.
so it is 1.14.
1.14.
So, we are getting it
44.
1 point
1.40.
okay, ठीक है ठीक 1.40. So, enter. It will be antenna phase center करेंगे.
हाँ नहीं माउस करेंगे. हाँ इसे 10 सेट आएगा. 10 सेट.
So, measure. So, it has started measuring. So, this is the time to go, that means minimum 8 minutes we have to take. We may increase also, if we increase, if we go on taking, it will take. So, that is what we have to do it. Now, in the meantime, if we can see that the PDOP is 2.3 and the height of the antenna is 1.400, what we have entered, that has been given correctly. There are 6 satellites and these are the 6 satellites which can be seen now. So, in this way we can list also these satellites, their angle of elevation, then other parameters. So, once the observation is over, then we can stop by giving abandoned points, yes. So, we are about to complete our observation of, so you are now completing it. So, only 14 seconds, now 12 seconds, 11 seconds. You see, once observation is over, again it is tailing measure, that means we can go to next point and we can take our next observation. That is all about the demonstration of static method of positioning. So, I like to conclude my class, today's class, and the next class will be on GPS position. Thank you.